Hello and a big welcome back to all of my subscribers, and if you're not a subscriber, why not? Today I want to go into some of the software I plan on writing for this Motorola 68K CPU homebrew computer that I'm going to build. I'm still waiting on parts for the wire wrapping. Should get some of those in from China today or maybe sometime later next week. But anyway, I'll show the hardware build as I start to do it. In the meantime, I've been working on software using the QEMU emulator. So I thought I'd just quickly walk you through that. Now, what you can see here is basically what I've got loaded up on GitHub. So I've been writing some of this. I documented it on GitHub, and you're free to, have a look at that. I'll put the link into the settings of this video. But basically, I've documented it as well as possible with the chips and what the code does, and how you can get the repository, and then how you can run it with the emulator. Now, at the moment, I have been focusing mainly on the bootloader.s, which also does the post. So let me just show you some of that. Now, basically, 68K starts at 0. It looks for its first instruction at 0, and then you have to set up the initial stack pointer. In this one, I have put this into RAM, and in my build, it will it's memory mapped IO. So I need to put the memory mapping here, and then it's the top of the memory. So that is my initial stack, but in the emulator, that is largely irrelevant. So in the emulator, I've just been using 8 megs of memory so that it's got enough, and I don't have to worry about it. I've got 2 globals in the bootloader, which is start and post. Post stands for operating system test. No, it doesn't. What is it? Sorry, yeah, it's actually power on self-test. I couldn't remember that for a minute. Right, so so I've got the global start, and then it goes to power on self-test. And down here I have a conditional entry for monitor. In the future, I want to write a monitor program, sort of like WASMON or the tutor program for the 68K, and I've put in wireframes for that. But actually, at the moment, all I really needed to do is to run the post tests. I'll work on the monitor next, because obviously that will work in the emulator, and there's no need for me to sort of have the actual hardware, so I can do those sorts of things, in the emulator. Now, the problem I'm going to have is that in the emulator, I can't spoof things like SPI or bit banging or whatever. So some of the things in the monitor I'll just won't be able to do. Much like many of the things in the bootloader I haven't been able to do. So what I've been doing is basically the start of the bootloader, and then it jumps to post, and then when it comes back, if it is available, it jumps to the monitor entry. At the moment in the make file, I've made it so that it doesn't do that, because I don't have it, and then it just jumps to the idle loop where it just sits there doing nothing. So when you turn this on, it just goes to a sort of a black screen in QEMU and doesn't really do anything, but you can connect to it with GDB, and you can watch it step through all of this stuff. Now, in the post, it does a memory check. Well, what it eventually will do is a memory check, UART check. It'll check the SPI, which is in the VIA chip. It'll check the IC2, which again is communication through the VIA chip. And then it'll check the LCD, which is another SPI device. And then, assuming all tests pass, it quits. Now, at the moment, most of these don't work, so it just posts errors. The memory check, I have tested it. The memory check is good because it can do these checks in the emulator. So eventually, I will do that. The monitor program is what I'm here in the main. So the idea here is that we start with the monitor program, and then it loops through and it catches commands. And the idea here is that I've got a lot of commands that I want to do: memory inspect, memory modify, block fill the memory, etc. Display registers, display addresses, set program counters, status registers, supervisor stack, all that sort of good stuff. Handle I/O, UART. Now VGA, I have a thing called mod VGA coming in, which hopefully will be delivered today, and that is controlled by an Arduino. It's basically a hat for an Arduino, but it will give you VGA keyboard input and output, and it works via SPI. So I should be able to bit bang that in the CPU. And then these memory functions. So the monitor program realistically is just the sort of same as the tutor program or some of the basic stuff you get in Wasmon. Eventually I want to write an actual OS for this. So with that in mind, I have looked at doing some things which I'm going to have to, work on a lot, but, malloc, free, all of those types of things. I'm going to need a sort of standard library if we're going to, work with this decently. What else we got here? I plan to do a FAT32 implementation on the SD card because it will support the SD card. Again, this is SPI. I have worked on a fair amount of these as well. The UART initialization check, things like that. However, much of this I cannot test until I get the hardware. So although I have been working on the software, there's not a lot I can test without significant modification to the emulator, and I don't want to spend my time rewriting emulators. What I actually want to do is, write code for the actual hardware, because this is an exercise in me learning. So at the moment, the bootloader is the focus. I have got this running. The bootloader does run. So if I run it, there you go. Not a lot happens. There isn't really a lot you can do with this, but it does show you what's there. And if I connected GDB to this, I could do some debugging and show you that. But that's where we are at the moment. So at the moment, I have basically just got to the point where I have some software that I can test on the emulator, but because I'm restricted, because I don't have the hardware, many things like I can't test. I can't test the mod VGA. I can't test the LCD screen. All of those things that are actually connected. The UART, I need a serial connection. My plan is to basically get the serial connection and connect it into my computer and use the serial connection on UART as the sort of default standard out. But that's where I am. I hope you stick around. Hopefully next time I will have been working on the hardware and have something to show for it. I've had to go buy a new perf board because the other one has too much software and too much mess to use. But as I say, many parts still awaiting delivery, so I can't really do much with the hardware. And I've pretty much come to the limit of the software I can do on the emulator outside of continuing with the monitor. If anybody has any suggestions, let me know. If you like these sort of videos, please like and subscribe and all that good stuff. And I'll see you next time. Thanks for watching. Bye.